There.
It should be Indy Gaskins.
Can you hear us?
Yes, I can.
Okay, great. So this is a meeting of the Public Safety Committee. I'm John Bogosian, and I think the first thing, I don't know if you just want to introduce yourself and maybe spend 5 minutes or so explaining your proposal and how it meets the criteria that we set out in the RFP. And then that would allow us time then for some questions that we have.
Okay. We have a little PowerPoint presentation that we've kind of put together for you guys, and then we can kind of go through questions at the end. I'll introduce myself. I think Jeremy looks like our technical support manager is on the line as well. My name is Andy Gaskins. I'm with Cubic. I'm a sales rep that represents the state of South Carolina, North Carolina, Virginia, District of Columbia, and Maryland for our Trafficware and GridSmart product lines. I've been with the company since October of 21. I've had various industry experiences in sales. I'm well over 25 years in sales now. I've been in pharmaceutical sales. I worked in the beer industry for several years. Most recently, prior to this job, I was with Ferguson Enterprises in underground utilities. So got tons of sales experience, lots of industry experience, and this October will be my 5th year with Cubic. So still learning a lot about the traffic industry myself. Have tons of customers in all the states that I cover. Specific to you guys, obviously in South Carolina, Trafficware and GridSmart are heavy in the state of South Carolina. South Carolina DOT uses Trafficware and GridSmart products. They have our ATMS, Advanced Transportation Management System, central software. They use our controllers, hardware, cabinets, like I said, the GridSmart video detection system, and got great relationships with those. A lot of those agencies, all the districts, all the SCDOT districts across the state, numerous municipalities such as the City of Greenville, Columbia, and Myrtle Beach, Charleston, and various other municipalities across the state are heavy users of our products, and we have really good relationships with all those people. And I'll kind of turn it over to Jeremy Dixon to let him kind of introduce himself a little bit, and then we'll kind of go from there.
Hello all. Sorry I'm not on video. I am traveling today, but my name is Jeremy Dixon. I am the technical support manager for Cubic. I've been with them since August of 2016. I do handle the support for all of our products. 30 years in the industry, working on traffic-related equipment, and I'm out of Dothan, Alabama. So.
Thanks, Jeremy. I'll go ahead and share my. Go ahead.
Yeah, go ahead.
Yeah, I'm gonna take myself off camera and I'm gonna share I'm gonna share my screen with you guys.
Andy, while you're getting that ready, just so we're all on the
Yes,
same
sir.
page, we have the next interview scheduled at 11:25. So.
Gotcha. Yep. 15 minutes. Yes, sir.
Yep, thank you.
Okay. Yep. This try to get through this as quick as I can, and then we'll leave some time for you guys at the end for questions. So obviously we're doing a presentation for you guys for the city of Alcoholms for AI control traffic signal system RFP. Just a little bit about who we are. Cubic, 2,900 employees worldwide, 50 plus years of transportation experience. We've got long-term partnerships with customers well over 30 years. Cubic is a company that's based in San Diego, California. We have manufacturing for the traffic side and the traffic engineering specifically in Knoxville, Tennessee, which is where our GridSmart product line is, and Tullahoma, Tennessee, and Sugar Land, Texas, just outside of Houston, for our Trafficware product lines. We all of our controllers and cabinet hardware. We are a trusted Build America, Buy America compliant manufacturing partner. We've got unmatched expertise and support nationwide with local FAEs and distributor partners. And we are an industry leader as far as helping to define the industry standards. We have had a lot of employees over the years that are involved with a lot of the organizations that actually help keep the standards up. Specifically, kind of one that comes to mind is California Transportation Caltrans that we've been heavily involved with over the years. Cubic Transportation Systems, we're heavy into providing essential information and payments capability to allow agencies, operators, and patrons to increase efficiency and reduce congestion. So just a little bit about Cubic quickly. We have various divisions in Cubic. There's a defense division. There's a CTS division that kind of handles fare collection. They make the hardware and software for the busing systems in major metropolitan areas and subway systems. And under that umbrella falls the Intelligent Transportation System, or the ITS division, which is the specific to traffic signals in the municipalities and DOTs across the states. We're into delivering integrated solutions that keep people, vehicles, and cities moving efficiently while building transportation networks that are safer, faster, and ready for the future. And this is kind of a roadmap picture of what we offer within a particular, set of ITS kind of divisions and solutions that we provide. You can kind of see at the top there has a little detection box that has a little GridSmart camera circle. That's the GridSmart video detection system that we'll talk about a little more in detail. Adaptive signaling is our Synchro Green adaptive signaling. That's part of our software package that we offer. Traffic controllers, a central management system, which is what our ATMS that we're going to talk to you guys about. Signal performance measures for the actual measures of the actual traffic signals within a given municipality or DOT. We do emergency vehicle preemption, transit signal priority, and arrivals and departures software. So a lot of cities obviously face seasonal congestion. You guys specifically being Isle Palms, probably heavy traffic during the summer months. Our big job to do is to help alleviate that, along with intersection safety, protecting, the VRUs, we call them those vulnerable road users, the pedestrians in the downtown areas crossing intersections, the bicyclists, and so on and so forth, and help reduce slow response times through, congestion management. So the solution, we're a proven partner. We have proven products that have a very long track record. Our goals are, number one, to increase safety. Number two, to reduce travel time. 3, manage travel operations. And 4, optimize data in real time. So our approach, obviously for you guys specifically to this RFP, we would provide a pedestrian safe controller. We have industry leading software on that particular controller that helps manage the intersection, and it is SCDOT approved. This particular controller for you guys would be a 2070 LX model controller. It looks very similar to this one in the picture. Intersection safety, this is our GridSmart video detection system, which has a 360-degree fisheye camera. It's viewings for enhance that vulnerable road user safety, situational awareness, and intersection monitoring. Obviously, let's do the other things that are listed here. And then real-time adaptive is a Synchro Green that we're going to talk about. It automatically analyzes and adjusts signal timing in real time based on live traffic conditions. So the pictures below are the people that will help talk with you guys going forward if you decide to move with us. Steve Carver is our Synchro Green and software development head. Matt Greeno is one of our technical support leads. Derek Spatafor is the next picture. He's the local field application engineer that would come down and do installations, troubleshooting. He would be kind of your technical person that you would call for any kind of issues that you're having, either software side or manufacturer or hardware side. And there's a picture of myself, obviously. So a little bit about Synchro Green and the adaptive signal control. It kind of utilizes the best of 3. Synchro Green utilizes a 3-engine optimization algorithm, where most adaptive systems kind of utilize just one of the 3 variables, which are splits, cycles, and offsets. It's corridor level optimization that adjusts signal timing on corridor and network rather than site by site. So if you have a specific corridor that's heavy congestion, corridors that are around, malls or schools or event centers, corridors leading into vacation areas such as yourself, Synchro Green is a great option. With Central system, it anticipates high volume events to prevent queues and keep traffic flowing. It's also heavy into cyclist protection, dedicated bike signals and phases for built-in cyclist protection, extend or shorten green time according to cyclist speed. Pedestrian protection, which I know is a very big deal for everyone. Detect pedestrians and prioritize safety while optimizing signal timings. Extend or shorten green time according to pedestrian speed. And vehicle preemption priority. It helps maintain that EVP functionality, and it also integrates the transit signal priority for optimized multimodal travel. Synchro Green's been around for 15 years, hundreds of systems deployed, well over 2,000 adaptive intersections at this point, so it's a very proven adaptive software option for you guys. The three-factor optimization approach just kind of describes a little bit about what it is. Cycle links, splits, and offsets. So kind of the bottom picture there shows, 3 is better than 1 as far as being able to use all those factors for optimizing the timings to help reduce backups and distribution demand. The adaptive advantage, it increases traffic flow by 20%, which helps 6 hours in actual time savings, people traveling per year, and, can help save gas, $45,000 per person or per intersection per year. This would kind of be just a general project plan that we would put together, and you can kind of see in here the first quarter, we would kind of do a project management pilot. We would come out there and we would do data collection, get some things kind of going with that. Phase 2 would kind of be the deployment, prep, and procurement. Phase 3 would be the installation and configuration, and then phase 4 would be kind of an adaptive activation and calibration. The miles we've traveled since 1975, like I said at the beginning, 5 decades of experience. We're in 50 countries worldwide. Well over 10,000 specific customers have been served. We have 60,000 intersections managed, 500,000 devices installed. TrafficWare GetSmart is a known product in the industry, and we're excited to be able to offer this to you guys. Cubic, we're the market leader in proven success, global presence and local expertise, technological innovation, financial stability, and long-term commitment. We're here to provide whatever we can for you. We think we're a great option, and that's the presentation, and we'll kind of go with questions you guys may have.
All right, thank you. I've got a couple
Yes,
questions, and we can, anybody just jump in, but, so your adaptive controller, can you tell me specifically how it works? We're not a corridor, in fact, in the sense that we have multiple lights. It's one light. And
right.
That light backs up and creates gridlock. And so what we're looking for is a solution to that. But can you tell me how, I understand the detection, but then once the detection detects that there's gridlock, how does your adaptive controller work? How does it actually, the methodology of controlling the signal?
Jeremy, can you speak to that?
Yes. So typically what it'll do, easiest way to put it is it's going to grab volume and occupancy, and from there it's going to just cycle by cycle the lanes. Whereas a static timing, you would just put times in and you're pretty much set. But this would adapt cycle by cycle. So it's going to use some of what was there previous and also take what is there current to ensure that the timings are maximized.
So in real time, it's going to change the length of the light cycle?
That is correct, yes. So last cycle you might have needed 180 seconds to maximize it. Next cycle you might only need 150, and it'll do that for you.
What do you mean by maximize it? to reduce the gridlock?
Yes, it will reduce the gridlock. Now, it's going to take the volume of the vehicles, as I said in the previous cycle, as well as what's currently there, and from there it'll step the timing up or step it down based on the need, which maximizes. I mean, it just adapts the overall length of each cycle from one starting point till it gets back around that movement. It will maximize the times for all the different movements in that cycle.
Anybody have any questions?
I had a question. One of the unique features of the geography here is there's a huge S-curve. And I'm looking at the presentation here. The question I had is that a problem if there's no capability beyond the line of sight? Or is there a capability beyond the line of sight that somehow helps factor it in? Because you can probably see about 300 yards from the intersection due north, and then beyond that, you lose track of all the traffic that's backing up to the north in the direction of Wild Dunes.
No, 300 yards is more than enough for us to be able to utilize all the tools we have.
One question we had is, does this require an SMA with SCDOT? Or is it compatible with SCDOT?
When you say SMA compatible with SCDOT, so a lot of the municipalities in the area actually utilize SCDOT to be able to kind of piggyback, quote unquote, on those kind of things. So that would be an option for you guys to be able to do that?
Yeah, it's a SCDOT signal and box.
Oh, then, yeah, absolutely. You would absolutely be able to utilize that.
So you wouldn't need to go.
So they own it, you guys maintain it, is basically what you're saying.
Well, would they need to maintain it? Are your products, would they need to go into an SMA if they installed this? Or would it still be able to stay on the DOT maintained system?
Yeah, we do not currently
Is this-
maintain it. They maintain it.
Okay, well, there will be the local SCDOT district that would maintain it, which would be, for you guys, potentially, I'm not sure, I'll have to look, I'm not sure which district that would be,
It's District 6.
but it would be the local DOT. 6, okay, yeah, it would be 6 then.
I have a question. I just want to make sure I understand your cost. So what is your total installed cost for the project?
Let me see if I can grab that real quick. I'm sorry I didn't have that ready.
But pushing back on that, is there network or communication to this location on the SCDOT network?
Is there what?
Network
Communi-
connected.
Yeah.
That would need, I'm not sure, that would need to be confirmed. Or it may need to be added.
There's obviously a camera.
Yeah, but that's run separate.
But does it have like cell communication?
I don't know. I don't
Yeah.
know if it,
That would need to be confirmed.
Okay. Thank you.
Sorry, I'm trying to find, I've got 15 screens open and I'm trying to find this, proposal. I don't know if you guys have it available.
Well, I do. I
Um,
have a grand total. It says $157,494, and then it says total without optional items, $110,000.
And the optional is ATMS and adaptive turn on configurations has minimum sufficient reporting outputs for system design and planning. Mandatory task 1.
Yeah. So I'm just curious of what that, you know,
What's the optional
what's the optional,
component?
what disadvantage does that create if we don't do it with the optional? Or what advantage does it give us to go with it?
Having it, so this will be, since you guys don't manage the intersection, this would be more for the local district to be able to tie into the state's ATMS networking for that particular intersection. That's the cost, that's that cost. If they decided they wanted to have that intersection on their statewide ATMS central system, that's that cost there. If you guys did not want to be a part of that central system and have that, it would just be the 100,000 costing. So the additional is the ATMS, which is the advanced transmit, the system that they would actually manage from their local district.
But what would they
That means
manage?
they'd be able to have access to that.
Manage what? Manual operation of the signal?
Yes, they would basically be able to get reporting. So the ATMS goes to a central system, and usually there's a TMS at a particular location, whether it's the local districts or Columbia HQ headquarters. And there's someone that basically can go into that system and look at those intersections, or for your case, this particular intersection, and say, hey, this intersection is operating well, there's an alert. They actually get alerts if there's an issue at the intersection, and they will be able to go into the actual system and manage it from there. They wouldn't have to actually go out to the signal or the cabinet, pull it up and see what was going on. They'd be able to manage it from their local system, which would more likely be at the district office.
Okay. But without that, so in other words, to be able to manage that light manually without that optional item, you would have to go and open the cabinet and operate it?
Yes, sir, that's correct. Go to the actual cabinet and troubleshoot whatever the issue is.
We can just talk about that later, I guess, but we understand it. All right. Any other final questions before we let them go? All right. Well, thank you very much for your time, and we'll be back shortly.
Thank you guys for the opportunity, and you can feel free to email me for any questions you have. I can provide any additional information, and we look forward to hearing from you soon.
Okay. Thank you.
Thank you.
Thank you.
So Terrace is next.
Yeah. My glasses, I can't. They in here?
Yeah, I think we're looking for Lorinda.
Are these things 20 minutes or 15?
15. Yeah, sorry.
Yes.
Hello, can you hear us?
Yes, we can.
Yeah, okay, great, thanks. Hi, I'm John Bogosian. This is a meeting of our Public Safety Committee here in Isle of Palms. And as you know, we're reviewing the RFP proposals for our signal project. We got a pretty close time frame here, about 15 minutes. So if you could spend maybe, I don't know, somewhere around 5 minutes or so explaining your proposal, 5 to 10, and then allow us some time for some questions, that'd be great.
Okay. We have a kind of a quick deck to share if that works, and then we can demonstrate some things, but we'll be fast.
Okay.
And if you have any follow-ups afterwards, if you want to talk to us further, that's just let us know.
Sure.
Natalie, you wanted to or Mark, you want to display the PowerPoint, or you want me to do it?
Yep, no, I can drive. Can you guys hear me?
Yes, although you're repeated.
All right, I'm getting enough. Let me share my screen.
So that's signal.
Yeah, Mark, you got a lot of feedback. Your mic.
Is that me?
Yes.
I don't know how to stop that.
Do you want me to take over?
Yeah, please. Let me drop and join again, sorry.
Sounds good. Can you see my screen? Okay.
Yes, yeah, it's great.
Great. All right. I guess, I don't know, Mark, if you can talk, you can go through this part. If not, I'll go ahead. Just by way of introduction, thank you for having us today. I'm Scott Burley. I'm the Vice President of Solution Architecture. I'm here with other team members who will kind of introduce themselves as we go along. We have some experience in South Carolina. We wanted to talk about the product offerings that we put in our proposal, which include AI-based sensors to support the kind of use cases that you have, and then a ClearGuide application that monitors the elements. We'll go through those in brief, and I know we have a very short time here today, so I'll be very quick. Nader will also present our solutions, and then Mark, who's having trouble with audio, was going to do this part, so I'll run through. So I guess for the background, we have a long track record of innovation in our traffic detectors, as well as our analytic software applications. We're dedicated to producing one of the best, most accurate leading detectors on the marketplace. We have over 200,000 sensors that are deployed nationwide, and we have billions of detections per day, and lots of customers who like our stuff, and so we're hoping that you will too. In terms of the software experience, we've been supporting the state of South Carolina with an application called ClearGuide, which is our analytics real-time traffic processing solution. We work with the traffic operations division at South Carolina DOT. They've been licensing our software since 2018. And we also support the 511 application for the state. So we've been doing that since 2013. So we have a kind of a rich history of understanding the state and its solution sets. And so we're excited to help you here for the intersection and the IO problems. Next, I'll just turn it over to Nader to go through the detection components, and Nader, just prod me when you want me to go on to the next slide. You're muted, it sounds like. Hopefully you don't have me walk through this section. Still audio problems.
Joshua, can you unmute her?
Are you able to be heard? No? Okay, so with the time, Grace or Mark, if you want to chime in, we have a solution we call Vantage Apex that's used for shelf mount solutions. It has an NVIDIA processor in it to do the AI detection of the zones that the traffic sensor monitors. It can work with a variety of different types of sensor devices. So this is the thing that goes in the cabinet, and then the sensors, depending on which sensor you feed it, you get different information from the intersection. It's sets up with zones that you define for the areas that you want to monitor, and then you can use that to measure and manage the intersection accordingly. One of the sensors that we propose to go with this solution set is called the Vantage Vector. It has the ability to see both visually and with radar detector to monitor the intersection. So you can get things like you have a high speed approaching the intersection on the connector, and so it has the ability to trigger different elements inside of the detector to make different decisions with the traffic controller, and so it has the ability to have different trip lines for different distances. It has a high resolution video that allows us to monitor traffic and all the different types of movements, including pedestrians, really well. So that's the kind of the solution set that we're providing for that. So this is an example of how it detects. So it's able to measure the vehicles, the bikes, the pedestrians, all at the different parts. software solution set that goes into this service is called Apex, and so the proposal that we've provided to the in our response will allow you to measure all these types of users, so that at this kind of complex intersection where there's a lot of different types of users of the area, we'll be able to use the AI models to be able to support that well. Nata, are you on audio now? Just some more examples here. The Apex solution, as it's monitoring things, it can help with pedestrian timing. It can enable lights to trigger from when in dark. So when you have problems with pedestrians in dark situations, it has the ability to trigger lighting systems. In some cases, we didn't propose that for this solution, but it has. Having the solution set will allow you to could allow you to do other things like lighting and blank out signs to warn vehicles of pedestrian presence based upon what the detector can read. Natter, can you speak yet or not yet? Doesn't sound like it. So the advantages to our solution sets, we have the ability to see both things in terms of video as well as the distance from the detector. Yeah, we can hear you.
All right. Could you back it up just a moment?
Sure.
Sorry about that. And you're doing a great job. But back up one more slide. So this pet onslaught that we call, the key to it is we identify every possible type of roadway user, and we identify the type, not just that they're there. So pedestrians, bicycles, cars. This is going to become a big deal when we start talking about the next slide. And I think it's a big deal for Isle of Palms because of the, I saw that you have a lot of pedestrian crossings, much more than traffic signals, but the pedestrians are something that we could do something about, not only at traffic signals, but also at mid-blocks, mid-block crossings and that type of thing. So in this case, we're showing that we actually do things in real time. When we see a pedestrian, we not only give them additional timing if they're walking slow or whatever, but we also turn on warning devices. 80% of pedestrian fatalities happen in dark hours. Notice as they walk out of this crosswalk right here, when they're gone, we're going to turn off some supplemental lighting. Doing things in real time is what Iteris is really all about with our latest detection. Okay, next slide. Thank you. And so it is truly a hybrid sensor. It does have a complete radar system as well as the video system we've just been showing you. And with this, it's all about safety applications. The video I've shown you identifies clearly bicycles, pedestrians, and can do something about it in real time to protect those users if they're in crosswalks or if they're mid-block crossings, if we have the right things. Anything from changing signal timing to turning on warning devices, blank out signs, all types of things to protect bicycle riders and pedestrians. And then there's the radar. The radar is actually a pretty remarkable thing because it gives us information we've never had before about vehicles. The PD knows all about radar. It's all about position and speed. We don't care just about speed, but position and speed. If you go to the next slide, this is how we, again, use it in real time. We are not only monitoring the position and speed, but we are predicting red light runners. This allows us to do something about them in real time before they actually cause an accident. So we're not looking at near misses, we are preventing near misses. Next arrow down. So when we see a car and we know that they're going to run a red light, and I can explain to you if you want to know how we do this, it's very simple. We go to a feature the controller already has, which is a red extension time. And we place a hold on that red extension time, arrow down. And we keep that hold on until the car, one more arrow down, is completely out of the way, and then we release the cross-street traffic. And so, is this effective? How well does this work? Next slide. There was a federally funded study in Southern California by the Southern California Association of Governments, biggest MPO in the country, that equipped 49 intersections in the city of San Bernardino with this technology. So we're monitoring for pedestrian, bicycles, everything at the roadway, but we're also monitoring and predicting red light runners. In a 5-year history, crash history. This isn't estimating how much the savings would be. In the before study, 4.74 years, 67 fatal and serious injury accidents. That's an average of 14.1 per year. After, for a full year after, 1.15 years, they only had 3 fatal serious injury accidents. Annualized, that's 2.6. That's an 82% reduction in fatal serious injury accidents by using this technology. Again, we do the same thing not only with cars, but we also do the same thing with pedestrians. The same feature in the controller that allows us to do this. When we see pedestrians that are still in the walkway, walking slowly because they're elderly, or maybe there's a mob of them, like you saw earlier, crossing together, and they don't get across in the amount of time that you normally expect, we extend the greens to help protect them. This study showed a reduction in crashes from vehicle to vehicle, vehicle to pedestrians, and vehicle to bicycles all at the same time. So a tremendous capability there. With that, that's my last slide.
Did you want to go through pricing at all, or do you want me to go on a clear
I
eye?
do want to go through pricing because I was a little bit confused on what your pricing is.
Sure.
Okay. Mark, are you going to go through the pricing?
I can kind of help. I don't know if Mark has like full audio at the moment, but I'll do my best. So, did you have questions before we go through it, or you just kind of want me to run through it?
Well, what I have here is like something per detector, and I'm unclear at the end of this thing, how much is it going to cost us to achieve what we want to achieve?
Sure.
No, fair enough.
So let's talk about the hardware platform, what's required at an intersection. The cabinet processor system is the Apex. That's the name of it. The sensor itself is called the Vector. So normally you would have, if all you want to do is video only, you don't have to have the radar if you have really low speed approaches, depending on where you're putting it. So there is, but the Vector itself is the one that gives us all the capabilities we just talked about. And so you'd have one of those per approach. So a typical system is going to have 4 sensors, vectors, and 1 CPU, processor unit, Apex. And so I'm not familiar with what the pricing is on that proposal, but Grace, you can probably take it from there.
Nope, that's a great question. Yes, absolutely. So in terms of, I don't know, do you have like our pricing breakdown on the slide?
Yeah, so what we have in our proposal is $4,038 for Vantage Vector, $9,093 for Radius, and pending for Apex, and $0 for Clear Guide.
So the sensors are correct. The radius
We would need 4
vectors. And then the Apex sensor, in-cabinet processor, you need one of those. So the price said pending, but it's going to be, I don't know, Grace, if you want to give them a price. I'm not allowed to talk about pricing, so.
Yeah, I can do it. So for the brains of it, like just on the the CCU portion of it, it's a little over 10 grand, like just for the CCU. So it's actually 10,932, or I'm sorry, 10,392 for the CCU.
But
So it would be that plus the sensors for the Apex.
But is that all then for the programming, the installation, everything from a turnkey kind of approach to putting this in? Or is that just the cost of the CP of the?
That's just the hardware. We can certainly be there to support the installation of it. We don't necessarily charge for, our assistance for any of like our product support team, to be there, to be on site. There's no charge for us to be there for that.
We do have, and if we are capable of doing a turnkey, if that's what you desire, either by hiring a local contractor that you normally do business, electrical contractor typically, or we can bring our own crews out with our own bucket trucks and take care of the whole thing. Budgetary numbers, about $2,500 per approach is what it costs to install that equipment. So about $5,000 for installation on top of the 26 plus for the hardware for an intersection that has vectors all the way around. If you have lower speed approaches and don't want the radar, and the video does everything you want for safety, there is a lower cost, and we do have the option of camera only instead of a camera and radar, and there would be a price reduction for that if that's of interest.
All right, we're running out of time, but
Yeah.
I want to just make sure I understand this, because this isn't a corridor or a system of traffic lights. We're a one traffic
Right.
light town.
Correct.
And during the beach season, the traffic creates gridlock approaching this light in multiple directions. And so what we're looking for is, and I want to make sure that this Apex does it, but your detection and your analytics are extremely impressive. But I always want to make sure that it takes that data and that it can automatically change the signal timing in a way to improve and eliminate the gridlock. Automatically in real time. In other words, you don't have to then, AI isn't being used to generate data that then has to be input into the signal timing manually, that this is real-time, real changes to immediately improve gridlock.
Yeah. So what we do typically with the hardware integrated with the detection system is we leverage the capabilities of the controller itself. All the controllers have the features I'm about to talk about. But when we see a traffic backup and see how many cars are on the approach, and it's using all of its time, we dynamically change the timing in the traffic signal controller to compensate for those high speed or those high volume approaches. We have very similar applications running right now in Corpus Christi, Texas. That Causeway Bridge going from Corpus Christi to North Padre Island, Mustang Island, is extremely heavy 4th of July, spring break type traffic. So I totally get where you're coming from, and that's the features that we're using. Our detection, dynamically changing the signal timing in real time, and that is absolutely critical. In addition to that, we have a software package that lets us analyze what happened in the past. How many cars actually went through, what kind of delays, how far back they went. Scott, you want to go over those very briefly, but I think we're running out of time.
I reckon we're running out of time. I'm happy to share the deck with you as well. So I have some slides in here of the approach from across the bridge, and this is what we would provide you for Clear Guide. So you could have the both the monthly. These are monthly contours, meaning you can see every day the queue that's backing up, and you can tell the weekend traffic and what's happening around the 4th of July from last year, for example. And then in the signal trends element allows you to measure the performance of the intersection. So here you can see that the control lay on the sort of the smaller street that comes out into the intersection has a lot of delay, particularly through and left. And then you can use it to calculate how the signal performs. Essentially, it's a check on what the device is doing.
And these features here, my group in Austin, Texas, actually does this kind of function and timing adjustments based on the data coming here in real time for agencies all over the United States, everywhere from Florida to Hawaii. So that is our function, is to the detection and signal system will compensate for immediate changes, but long-term planning, long-term adjustments can be made, if you want us to do this, by traffic engineers monitoring the data and making the adjustments on your behalf.
So it sounds like it probably would be useful to have like a clear pricing for all of the approaches at the intersection. Is that a takeaway that you'd like us to?
We'll get back with them with any questions.
Yeah, we'll get back with you, any questions. I guess one last question that we want to make sure is that this is DOT, this is a DOT cabinet. And would this be compatible with DOT, or would we need a signal management agreement with them?
It would be compatible with the DOT hardware. We work a lot with the DOT in South Carolina on all types of detection systems, and it is completely compatible with it.
Okay, so they would not need to enter into a signal maintenance agreement?
So the signal maintenance agreement, I think, would stay the same as what you currently have if you're responsible for it, and they can reimburse you for maintenance, or if you're responsible for it and you're paying for all the maintenance, that wouldn't change. The detection system is considered an integral part of the control system itself.
Yes, they don't have a current SMA at this point.
Okay, so does the state currently support it?
Yes.
Okay, maintain it? Okay, yeah, then I think the appropriate thing is, that the state agrees that they'll continue to maintain this system for you as well. Obviously, you wouldn't have, for one traffic signal, you don't have a signal crew of your own, and the state should do that, but that is an agreement that you should come up with the state if you're not currently maintaining it yourselves. I used to work for TxDOT, so this is the kind of conversations I've had all the time.
Okay, well, thank you very much for your time. Appreciate it, and we'll get back with you with any follow-ups.
We will send you a clarification, because knowing the exact application here and the approaches, I will make recommendations to Grace on the actual equipment needed, and we'll modify the quote for you.
Okay, thank you.
All right, thank you.
Bye-bye.
Thank you. All right.
Bye-bye.
Bye-bye.
Josh, we got Reggie.
And we've talked to him. Good. Hello, Reggie, can you hear us?
Yes, good
Yeah.
morning. How are you?
Hey, good morning. John Bogosian, this is a meeting of our Public Safety Committee. As you know, we're reviewing the proposals for the AI RFP. And I guess if you want to just give us a 5-minute or so explanation of your solution and what's in your proposal, it may be helpful.
That'd be great.
Yeah.
Yes. Let me share my screen.
And I know we've spoken before as well with you, but I think
Yes.
it's helpful to kind of refresh with everybody what's in your proposal.
Definitely. So very quickly, so this is the area that we are focusing on. So the connector is coming in, and traffic is spilling into the region. There's backup on Palm Boulevard. So how do we figure that out and alleviate the level of congestion? So some housing development, and again, too much detail, we can go into that later. So this is the proposal, if you looked at it. So the first one, right at the intersection, we're going to have an adaptive system, the in-sync adaptive system, and then we're going to have a queue detector, AI queue detector, somewhere over here. Again, I'll be visiting the field and look at what is available and then figure the queue detector out. The queue detector will send it information when the queue spills over, send information that the occupancy on the detector is high, and we will invoke a plan that adaptively moves traffic and alleviates the queue. So InSync has over 3,200 traffic signals across the U.S. And your neighbors are 100%. Mount Pleasant is 100% InSync. We have Aiken, South Carolina has over 17 signals on Whiskey Road, then Lexington County, and then both Richmond County across the state line in Georgia, Richmond County and Columbia County, they're pretty much almost 100% in sync. This is a result of the studies. Before, people have seen a 24% reduction in travel time where InSync has been deployed. You won't have travel time as much in this particular use case or application. You're going to see alleviation in the queue formation and delay. So stops have gone down by 60% and then 57% reduction in delay. Fuel consumption goes down by 15%. These are all results of independent studies. Emissions go down. Crashes, again, Virginia saw about 17% reduction. And for you, essentially, there are two tech that is going to be deployed there. And I will show you the first one is InSync. I can talk about the model, but let's look at the second one, the queue detector, which is a AI queue recognition system. This is live coming over from it's a Caltrans deployment. So we are using AI to recognize different objects. It has quite a lot of capabilities. Some of it you don't need. It can recognize pedestrians, bicycles. It can recognize different types of vehicles as well. So this is what we will use for queue recognition. And extremely accurate, over 99% accurate in its recognition capability. And if I may go back to my PowerPoint. So essentially, InSync is like having a human standing out at the location with walkie-talkie communicating with your queue detection system. So it's a rule-based AI, and as you can see, this is how it looks like. It's not looking at stop bar detection. It is every second looking at queue formation and then assigning green time based on that. It works out what is called a greedy algorithm. It assigns a token for each car that pulls up, and if a car is waiting there for 5 seconds, gets a subsequent token. So the algorithm is greedy. It changes the green signal to give out the minimum number of tokens. So we have, again, yours is not a unique issue. We are currently under contract with the city of Miami Beach. Again, you have this 71st Street that is basically dumping vehicles into this island. They're actually on the project scheme. We have 2 of them. Here we have a drawbridge, which adds quite a lot of complication to how traffic is managed. So this is another solution. With that, I'll stop and answer any questions that you may have.
So as you're alleviating the queue in one direction, it's building in the other direction. So do you need a detector on the other side as well to detect how that queue's building as you're alleviating it coming from the opposite direction?
We are looking at the queues for all 4 directions and alleviating that. But here, when I looked at your problem, it was mentioned to me that the queues on Palm Boulevard would back up all the way over here.
It would,
So-
and beyond, way beyond that, I mean.
Yes,
for miles
so
down.
that's
But-
where my
But it
my
also
field
comes
is.
from the other way as well, so less so, but it comes from the opposite direction too. So as you're alleviating the queue coming one way, it's going to build back the other way.
Yes, if that were to happen, and if this is not able to solve it, then we would consider installing another queue detection over there.
Okay.
So we can, but initially, we don't need to do that. We'll basically deploy like this design first, unless, I'm in the field and I'm noticing the queue spillover, but I wouldn't recommend that right now. So this system is very modular. You can add on as much as you want. So again, one more thing. So we're looking at every second the queue on all 4 directions every second.
Yeah.
And if it is 100% all the time, that is going to get more time. So right now, as you can see, the queue is the occupancy, which is a metric we are tracking every second. That is 0 right now. It's saying, okay, we are doing a good job of clearing the traffic. So whereas here, as you can see, the occupancy is extending beyond what a human eye can see. The queue detection we added is for adding to this stop bar queue detection.
Yeah. But I was just wondering about the other way. I don't think you got enough tokens to give those cars on coming one way. You may have to order a few more.
I imagine.
I guess another question I have is around the cost. It looks like there's a one-time cost of $127,400 in here and then a recurring license costs, I guess. But that doesn't include the installation. You don't do the installation, right?
We don't. We will work with a contractor that is licensed by SDOT. There are several that we have teamed with before that would install the system.
Do you have an estimate for what it would take to, I mean, ballpark, to install something like this? Is it?
I think for each location will be 7 to 10 in that area. There are some contractors we will not recommend working with, just from experience with Mount Pleasant and Aiken and Lexington. But there are some that are trained and approved. So you have to be an electrician that is approved by SCDOT.
So when you say each location, 7 to 10, that's per light? So we'd have one location?
So this would be the most, because there are 4 cameras. They have to stop traffic to get in the middle to install the cameras. But the other, that'll be, we will determine that. It has to be on a city right away, maybe a luminaire arm with power. We would need power. So it depends on what we have available. So that everything is just, it'll be a NEMA box that'll be mounted on the pole. That'll be less expensive.
Okay.
But I have not visited to locate the installation location.
I guess the one other question I have is, you in Mount Pleasant, where you have multiple applications, are they also using Cyclops, the AI implementation?
They're not using Cyclops because they have InSync, which is a fully automated adaptive system. But they have a couple of locations. I think they've upgraded to InSync AI, which is this type of Q detection. The one I showed you.
Is the Cyclops, is that what you're recommending for our application, or InSync?
InSync. So it will be InSync. It will be InSync here, which is adaptive, and this is the Q detector, which will be the Cyclops.
Okay. I don't know, you guys have any other questions?
What about, Reggie, about interoperability? If Mount Pleasant is using a similar system, if that was envisioned down the road at some point, is that feasible or not feasible?
Fully interoperable, fully interoperable. And also their team can provide some tech support as well. So if you were to enter into an interagency collaboration, they have connectivity to all their signals. If there was some issue, you need an evacuation route, there is quite a lot of possibility of working with James Aton. And they're pretty, they've been operating for over 12, 15 years.
I guess one last question that we have is, well, maybe last, I don't know, but another question is, this is a SCDOT box, and would it require us having an SMA with DOT or not?
It probably would. Like we are in quite a number of them. Aiken is 100% SCDOT boxes. City has a simple one-page MOU. You can agree to maintain it, and that should be a pretty easy thing.
Okay. Any other questions? All right, Reggie, thank you. If we have any follow-ups or anything, we'll get back with you.
That is perfect. Thank you so much. We're really, really looking forward to this project and working with you.
All right, thank you.
So take care. Bye-bye.
So, are we going to go back live now?
Yeah.
And we're
Josh, we'll go in.